Amy, Beth, Kathy, Dorothy, and Ellen brought salads to a potluck picnic in identical bowls with lids. Luckily, each of them labeled their bowls and lids with their own names. After the salads were eaten, someone randomly placed lids back on the bowls without checking that the names matched. What is the probability that at least 2 lids were placed on bowls with matching names? Alright, well, probably the easiest thing to do here would be to do some casework. Alright, so when we say at least 2 lids being placed on matching bowls, we either have exactly 2, exactly 3, exactly 4, or exactly 5 lids that match the bowls. Okay, so let's look at each one of those cases separately. So first of all, let's look at the case where we have exactly 2 matching bowls and lids, and the rest of them don't match. Okay, so 2 match and the other 3 do not match. So let me draw some bowls here. So you have 1, 2, 3, 4, 5 bowls. Okay, now we need to choose 2 of them that match. Okay, so we could choose, let's say this is Beth's bowl and this is Dorothy's bowl. Okay, we could choose those 2, or we could choose Amy's bowl and Kathy's bowl. But it doesn't matter whether we choose Kathy and Amy or Amy and Kathy. Okay, so the order in which we choose the bowls that we want to match, doesn't matter. So we just got to choose 2 of them. So we have 5 choose 2 ways. It's a combination. So let's say, for example, we choose, I don't know, let's say this one and this one end up matching. Okay. Then, okay, so we've chosen 2 bowls to match. We have 3 bowls left. Alright, so let's look at what we can do. Now, the rest of them cannot match because we're looking for exactly 2. Alright, so we have 3 bowls left, and we've got a pile of lids, 3 lids, okay? And since these 2 match, we've got, you know, the lids that we have, if say this is, let's say this is Beth and this is Dorothy's bowl, then the lids that are left over will be Amy's lid and Kathy's lid and Ellen's lid. But now we don't want them to match. So if say this is Amy's bowl, we can't put Amy's lid on Amy's bowl if we want exactly 2 matches, because we've already chosen the ones to match. So we have 2 choices for lids to put on this bowl, because it can only be the ones that don't match. So 2 of them don't match and 1 of them matches. So we have 2 choices. Okay? And then the other 2 lids have to go on these other 2, and they can't match, right? So there will be essentially 1 choice for this and 1 choice for this. Okay? Does that make sense? Because they can't match. So if we've got say Kathy and Ellen's lids left, well, I guess I could be like Amy and Amy and Ellen. So you know, we can't put Ellen's lid on Ellen's bowl, so that means we have to put Amy's lid on Ellen's bowl, and we'll have to put Ellen's lid on Kathy's bowl. So there'll only be one way to, when we have 2 left, we only have one way to place them so that they don't match. Okay. So now we can just use our multiplication rule. And so this is the number of ways that we can choose the 2 to match, and then we have 2 choices for the first of the remaining 3, and then 1 and 1. Okay? So 5 choose 2, that's 5 times 4 over 2. So it's essentially the permutation. We have 5 choices for the first lid, 4 choices for the second lid, but the order doesn't matter as far as whether we choose Beth and then Dorothy first, or Dorothy and then Beth first, so we have to divide by 2. Okay, and then we multiply times 2, and then the ones don't matter. So we end up with 20 ways where we can get exactly 2 to match. Alright, let's look at the next case. Let's do exactly 3 match. Okay, so again we have our 5 bowls. Okay, so now we want 3 of them to match. Alright, So we have 5 bowls. We need to choose 3 of them that match. Okay, 5 choose 3. Okay, so let's say we happen to choose this one matches, and this one matches, and this one matches. Okay, so then we have just 2 bowls left, and we've got to place them so that they don't match. Okay, so if this is Amy and Kathy, then we can't put Amy's lid on Amy's bowl because we want only exactly 2 to match. So we have to put Kathy's lid on Amy's bowl and Amy's lid on Kathy's bowl. Okay, so there's really no choice for how to place the remaining lids on the remaining bowls because they can't match. Alright, so it's just going to be one choice here and one choice here. So we just end up with 5 choose 3, which is the same as 5 choose 2, actually. You know, you can see that if you write it out. So it's 5 times 4 times 3 over 3 times 2 times 1. Okay, but the 3's are going to cancel. So 5 choose 2 is the same as 5 choose 3. Okay, so we get 20 divided by 2, which is 10 ways for that to happen. Okay, let's look at the next case. Exactly 4 lids match. Alright, so here's our 5 bowls. 3, 4, 5. We want to choose 4 to match. Okay? So we could say 5 choose 4, but we have an issue with this. So if I choose this one to match, and this one to match, and this one to match, and say this one to match, I've only got 1 lid left and 1 bowl left, and that lid has to go on that bowl, and it's got to be a matching lid. Okay? So this is automatically going to match. Okay? So we don't really have a case where we have exactly 5. We only have exactly 4 match. We can only have exactly 5. Okay? Because once 4 of them match, the last lid has to go on the last bowl, and it's automatically going to match. Okay? So there is no exactly 4. There's only exactly 5, and there's only one way to put all the lids on the right bowls. So we only have one way for that. So we've got a total of 31 ways that we can place these lids on the bowls such that at least 2 lids match. Okay, so we've got exactly 2, exactly 3, and then we have exactly 5. And so we have a total of 31. Now they're asked for the probability that you're going to have this case where you have at least 2 lids match. So this is the number of ways. This is the desired outcome here. This is our desired outcome. Okay, so that's going to be the numerator of our probability. So we need to find the total outcomes. So how many ways can we place the lids on the bowls just randomly? So we have 5 bowls and 5 lids, so essentially we just pick up a lid and we put it on a bowl. So we have 5 choices for lids for the first bowl, and then 4, right, because we only have 4 lids left. 4 choices for that bowl, and 3, and 2, and 1. Okay, so it ends up being 5 factorial, which is equal to 120. Okay, so that's 5 times 4 times 3 times 2 times 1. 5 factorial. Okay. So that's our denominator of this probability. So we have 31 desired outcomes out of 120 possible outcomes. So our probability is 31 over 120, which I think comes out to be about, I think it was 25.8%. So just over 25%. So there you go. There's your answer.